Morning. So we'll pick up kind of where we left off yesterday. So just to remind you all, we're looking at this OntoLex model, which really represents kind of dictionary-like information relative to ontologies. So at the heart of it, we have our lexical entry. A lexical entry has some number of forms. These are linking lexical senses to ontology entities. So we're going through the modules. We had a simple example here. We saw how we can add grammatical information to a lexical entry. We looked at lexical senses and how we use these to distinguish between different usages of a term. And then we started looking at the syntax and semantics. So we had this idea that you could have syntactic frames, and that you could say how syntactic frames map onto ontological frames, and we ended up with this kind of model a bit like this, where we have a syntactic frame with a number of arguments, ontological mapping which maps these arguments into a property which has semantic properties like its domain and range. So this is one of the modules of OntoLex. This morning we're going to look at some of the other features. So first of all, we're going to look at decomposition. So this is often a case in multi-word expressions, particularly in languages like German, where we have fun words like Qualitätsmanagement system, where we would like to know how a word is decomposed into other words. But we also end up with some certain kinds of effects when we join words. So for example, here, this German word here picks up an S, Qualitäts, even though actually in German, that word never occurs with an S at the end by itself. So you never have the word Qualitäts by itself. It's only, S only appears in compounds. So we'd like a way to represent this. So we have a fairly simple idea, but we have a lexical entry, which we can say has constituents, which are some components. And these components are also named URLs. So these also have names, which means we can then add properties onto the components. So we can say individual things about words as they appear in other words. And we can even do things like arguments and frames, and we can do some fancy kind of parse trees and such like in order to represent how a particular kind of very complex multi-word expression is working. So here's an example, kind of appropriate. We have summer school. Summer school is an OntoLex multi-word expression. So we can say simply that it has subterms. So subterm just means that another lexical entry occurs within this term. And while here, of course, it's subterm summer school, it's important to remember that in RDF, the order of triples is not important. Therefore, it is semantically equivalent to say subterm school summer. So we have no idea of order within if we just use a subterm link. Now, obviously, we can infer this from lemmas, but we don't fundamentally have this encoded in our data. So a slightly more sophisticated representation, and this is going back again to this idea of property chains, is instead of saying subterm, we can have a constituent that corresponds to something. And so we can say here our French term, école d'été, is another multi-word expression, which we say is composed of three words, école, de, and été. And here we actually use a slightly different mechanism. We use this kind of RDF sec mechanism in order to give the order as 1, 2, and 3. So we add an explicit triple saying which is the first, second, and third word in this decomposition. Then we can then talk about a particular component, for example, de, and we can talk about how this component occurs within the term. So in this case, we're actually going to say it's a contraction as it occurs in this term. That is, it's been shortened to just D apostrophe because of the following vowel. So we'll say that this particular de, as it occurs in the term école d'été, is a contraction. That's a particular word within a particular multi-word expression. Okay? So, another thing we're very important, we care a lot about is variation and translation. So, obviously, translation is fairly easy in many cases, but often we come across words that are difficult to translate or in fact impossible. So here we might have a Japanese word, this is mochi, and mochi could be translated as Japanese rice cake, it could just be mochi in English. There's lots of different ways to translate this, so we need to understand something about why we're translating a particular word, or how, or what are the conditions of our translation of a particular word. So this introduces the variation and translation module, which adds a load more vocabulary to do with mapping the kinds of relations. So we have lexical relations. Lexical relations don't care about meaning. So they're things like grammatical derivation is a classic example. We also then have relationships between concepts. Conceptual relationships don't care about the lexical form, they're more like things like synonymy or, don't care about lexical form, so they're things like antonymy or hyponymy. They're about the concept itself. But most importantly, for our point of view, we have these sense relations. So sense relations care not only about what word we're using, but also what that word means. So translation and many terminological relationships are examples of sense relations, so relationships between lexical senses. So this means that we can actually represent translation in a few different ways in our model. So here again we're looking at Japanese, so we have rice as our English lexical entry. So this of course would refer to the first kind of most frequent sense of rice as a foodstuff, but also maybe to other senses of rice within that same lexical entry. And then on the Japanese side we have this word, which is kome, and kome actually is more specific in its meaning than rice, than the English word rice, because it refers only to uncooked rice in Japanese. Cooked rice has a different word. And of course there will be other meanings that this word can refer to in Japanese. So we can basically represent translation in 4 different ways. So one thing we can do is we can just say that they both mean a single ontological concept. So the ontology representation is language independent, and we can say that this is the concept of rice, probably defined like the English concept to include both cooked and uncooked variants. And we can say that this English word and this Japanese word both refer to the same concept, and we know because they refer to the same concept in the ontology, that means somehow they must have the same meaning and therefore be translations. So this is the kind of implicit modeling of translation. The next option is we can actually say that they are translations. So we can add a direct single triple link. So we have a triple whose subject is this sense, this is a property translation, and this is the object. And we can link their senses. So we can say that this sense of rice, meaning the foodstuff, is somehow linked to this sense of kome, meaning the foodstuff. We also might want to actually introduce a name for this translation element itself. This is useful as we can then add in properties onto this translation. For example, we could say, who made this translation, or why did they do it, or when did they do it, perhaps. So we can add extra information by adding a URL for the translation itself. So the translation becomes named. And then this is when a model that's having a source link, which goes to the sense, and a target link that goes to the sense here. So finally, we can also just directly link at the lexical entry level, which we call translatable as, which is supposed to be a bit of a warning to people that this is not really a very good way to do it. And this is because it doesn't say that, it says that there are some meanings of rice that are translated into kome in Japanese, but it doesn't say which meanings. So we end up with much less power in this relationship. It's much vaguer linking, but it can directly say that this word is translated as this word, but it doesn't say, for example, which sense it would be. Now, actually, many dictionaries and terminological resources do just this translations like this, rather than doing it per sense, which is okay, but it's a much weaker relationship than saying things like, we know we have a common meaning, or we know particularly which senses are translated. So the final module that was part of the core was about linguistic metadata. And as it was originally proposed, there's a wizard and a djinn, and they're trying to talk to each other, and they both have their lemon models, but they have a different ontology. So if they could just understand the differences between their two lemon models, they could somehow combine them and have a conversation about magic. Yes. In reality, Lime is fairly straightforward. It is just a big bunch of properties that we have that can say things about a particular model. So we can say that these are data sets, they can be lexicons, they can be conceptual sets, they can even be link sets. There's all kinds of properties like number of lexical entries, number of concepts, average ambiguity, so how many senses do we have on average per word, and so forth. So this allows us to get a lot of facts about a lexicon. So these were the modules that were standardized in the 2016 version, but we haven't stopped since then. So we're now working on new things. We have a morphology module, which we have got a paper on at the ELEXIS conference in October in Portugal. We have the lexicography module, which is now released, which is trying to bridge a little bit the gap between our ontology and our RDF world and more traditional lexicography. Then under development, we have modules for frequency, attribution, and corpus information, which is called FRAC, and etymology and diachronicity, and we have lexicosyntactic categories coming. So here is sort of the lexicography module. It's fairly straightforward. We introduced this idea of a lexicographic resource with entries, which are more general than lexical entries. So unlike the game we played yesterday, there's really no restriction on what an entry is. It's just whatever you want to group together. You can group it as an entry. While lexical entry down here has the strict definition of exactly what an entry is. So why is this useful? Well, that's because probably NLP people and computer scientists want this. They want a very strict definition of entry. Lexicographers are like, no, I've been doing it my way for so many years, and I'm just going to have my very loose definition of entry, which spans multiple parts of speech and very different etymologies, and that's fine. So we have a way that we can allow you to both have general entries with no restrictions and specific entries with very tight definitions. So, one of the last things I'll say about this is OntoLex is, as I say, an open community group. You are all very welcome to join. Please consider going to the page at w3.org/community/OntoLex, sign up for the mailing list, join the telcos. You know, it's a good way to get involved, and hopefully you found it interesting enough. So we've looked at lexicons, so dictionaries are a very important kind of data, but perhaps a more numerous and maybe even more important data type is corpora. So corpora, if anyone doesn't know, is just basically a fancy linguistic way of saying a big collection of texts. And typically we want to be doing some kind of annotation over these texts. So I'll talk a little bit about two methods of doing annotation called inline annotation and standoff annotation. And then I'll look at three models that have been proposed for using linked data in corpus annotation. So, first of all, why would you want to annotate some bit of text? Surely, you know, with wonderful things like OntoLex that we've just seen, we've already able to represent all our information about language, all our information about meaning in our ontologies. Why do we need to go annotate corpora? Well, let's look at it this way. Ontologies capture facts about concepts, but not the usage of words. So they just capture the general meanings, but they don't really describe linguistics, which is why we introduced OntoLex. But lexicons actually only capture facts about patterns and systematic usage of words. That is, we describe how a word is used in general, but we never describe how it is used in a particular sentence. So, by definition, anything of interest to lexicographers is repeated. You know, it occurs, we have many instances of it, many different forms occurring in text. But actually, very often we would like to talk about a particular sentence and start to describe how that language is used in that particular sentence, and how this connects to the ontology. So what you might have seen so far is sort of inline annotation. So inline annotation is very typical with XML, and many of you have probably worked with something like TEI. Is that familiar to some people here, TEI? A couple of hands. So TEI is one of the most widely used methods or models in digital humanities. And this is, I believe, some kind of TEI data. So here we have a text here. And then what we do is we introduce certain XML tags in order to indicate certain things. Like here, this bit of text here, MXC, is a date, and then someone's translated it to 1990. Here, this is foreign text in French, je ne sais quoi, and so forth. So inline annotation is popular, but it has some nice, well, as a query, it's very easy, it's very quick to do. You just sort of, introduce it directly into your text. You can use your XML editor of your choice. But there are some disadvantages. First of all, we're very limited in terms of how much annotation we can express, because it has to all fit into a single XML tag, right? So if we're going to do very complex data structures, we're going to have trouble encoding them just in a tag and its attributes. Secondly, it changes the source document and it complicates the source document. So now, instead of our source document being a nice, easy to read text, this is actually kind of hard to read because you have to keep skipping over the XML tags. And as the annotations become more dense, you end up nearly losing, of course, the original document and end up with something that's illegible. Finally, of course, we can't then add annotations onto this document. So once it's annotated, it's done. There's no ability to later add more annotations. So inline annotations have some drawbacks, which is why many people have moved to standoff annotation. So the idea of standoff annotation is we now have our source document, which is unchanged, just as a plain document, and then we have a second file associated with it, which is our annotation file. And our annotation file is then simply a list of annotations which somehow point to our source document. So rather than having XML tags, we also can add annotations in a secondary file. So the method that the standardized method from W3C for doing this is called the web annotation model. And at its core, the idea of the web annotation model is that you have an annotation, so we can name and give a URL to our annotation. And this consists of two things. It consists of a body. This is all of the data about this annotation, so what this annotation is actually showing us. And a target, where the target is the document that we're trying to annotate. So we have some way of indicating which part of a document we're referring to with our annotation. So the body can consist of any element, typically through the object property hasBody, and then normally there's a simple data type property body value, which can give us a simple string annotation. But we can also use more complex multiple property structures for our annotation. The target is any element being annotated, and it has something called a selector, which chooses how we're going to refer to the document and how we select a bit of our target document to be annotated. So there's five selector types which are allowed in the standard. So one of them is the fragment selector. So the fragment selector uses the fragment specification defined by the representation's media type. So this means, for example, in an HTML document, for anyone who's worked with HTML, you'll know you can put ID equals and then a string onto a document. And in that HTML document, if you type hash, type a URL, and then you add hash and its identifier, then your browser will skip to that location in the HTML document. So this is the idea of a fragment, and we can simply select documents by whatever the source media or the target media type's fragment specification is. A second thing is we can do text So text cont defines a bit of the document by the text that we have, optionally with prefixes and suffixes before it, so we have a bit of context in order to distinguish which particular entity in a document that we're doing. We can also use text position, so we can use the start and the end position in the text. And data position, which is basically the same thing. The only difference, of course, here is that encoding, essentially, because data position assumes that you're reading in bytes, and text assumes that you're reading in some kind of Unicode character. And finally, the fifth one we have here is SVG selector. SVG is scalable vector graphics, so I'm not going to say anything about this because we're not doing graphical linked open data here, we're doing linguistic linked open data. But you can somehow select in SVGs. So, here's a simple example of a web annotation. So, as I was saying, we have a name for our annotation, so there's a URL, so it's example.org/name example. It is an example of an annotation. It has a body, this is a textual body. It has a format, which is text plain, and it has a value, which is person. And it has a target. This target is selected by a text quote, where that text quote is exactly James Baker. And it has a source, which is this URL, slightly abbreviated fit on the slide, but this is the URL. It refers to some particular document within the Penn Wall Street Journal corpus. So this is fairly straightforward. We have our annotation, we have a value to it, it's person, we're selecting everything that matches James Baker exactly in the document, and this is a document that we're annotating. So we can simply write all of our annotations using an example like this. Anyway, so here's sort of what we have a bit more graphically. So we have our named annotation. It has a body, which is a type textual body. It has two values, the format and the value. And we have a target. So we have a target which has a selector. The selector is of type text quote selector. It's mapping exactly the string James Baker, and it's referring to this source here. So that's sort of the anatomy of an annotation. So the web annotation is actually quite widely used, particularly in a few areas like biomedicine. It's a very nice kind of reified way of representing relationships. So we can do kind of many-to-many kind of relationships between our document and our annotations, which is nice. We can add all kinds of metadata, far more metadata than we could ever fit into our XML tags. So we have a lot more power than our annotation with XML. We can do all of the instances of a string at once using a text quote selector, it should say that. But as a drawback, of course, the web annotation model is actually very verbose. So here we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triples, right? So we have a lot of text in order to represent something that perhaps in inline annotation would be very simple. So, one of the solutions for this was of the NLP interchange format. So here the idea was to simply use URIs directly as targets, and also introduce some kind of ontology of linguistic data structures covering typical NLP cases. Or, of course, not covering everything you'll ever need, because we can't hope to anticipate this. So the NLP interchange format primarily uses something called RFC 5147. RFCs, for those of you who don't know, stands for Requests for Comments, and are these arcane plain text web documents by which a lot of web standards started out. But one of these was this idea of referring to plain text documents by fragments in text. So one of his simple idea is just to use character offsets. So here we could say with this document, and then we could add in this fragment. And if the fragment is form hash character equals, and then start and end, then we can be choosing a certain range of characters in a document. The RFC also defines some other things that are useful. So we can actually refer to whole lines. So we can look at line offset, so line equals 0 for the first line, because we're computer scientists and we start counting from 0. So the first line is line 0. And also quite usefully, because this is the web and documents change, we can also add in an integrity check. So this basically is a number that is calculated in a particular way from the document as a whole, and we can detect if our document has changed and therefore potentially broken all of our character offsets, then this number will change, and therefore we can detect at least when an annotation is broken. So this gives us some kind of power at least to understand when our annotations are broken. Of course, it doesn't give us any ability to fix anything if our annotations are broken, but we are at least able to see, okay, maybe these annotations don't work anymore and we need to find an older version of this document. This is of course an issue with standoff annotation, that the versions of the annotation file and the document file fall out of sync, then the annotations might not be valid anymore. So NLP, integrated format also define a bunch of generally useful ideas about how a text document is. So this includes general ideas like sentences and words and paragraphs and phrases, as well as ideas like heads, lemmas, stems, part of speech tags, sentiment values, ways to connect different strings like, where are they? So before and after, for example, showing the string that occurs before and the string that occurs after this current string, so we can connect words together. Or next word, previous word, next sentence, and so forth. So it defined a lot of general vocabulary about representing corpus and representing text documents. And in fact, you can actually use NIF and web annotation. So you can use this URL directly, this NIF URL, as a target. And this means that we've now, instead of having basically 1, 2, 3, 4 URLs here, we have a single, triples here. We have a single triple that's simplified with this RFC URL, which is of type NIF string. So this allows us to go and more simply represent a particular annotation. However, we save some triples, but the cost we have here is that NIF is basically not so well standardized and not so well supported as web annotation. And this slightly simpler method of reference it's nice, but it also means, of course, that we have to also support the NIF standard as well as the web annotation standard. So whether it's worthwhile, I don't know. So finally, we'll look at some work of a colleague of mine, which is on CONL RDF. So CONL is a very widely used format in NLP for representing corpora. And it essentially represents corpora as a tab-separated values, where there is one word per line, and then one column for each annotation type, with sentences separated by empty lines, and it's used for a lot of annotation, particularly in NLP tasks. So here is a typical example of a CONL annotated document. So we have a first column, which is the ID. So we have an ID for each of the words. We then have the words as they occur in text. So Sie dürfen eine Kopie der Software auf dem something something. We then have the lemma forms. So we see here, but most of these lemma forms don't change, but we see eine is lemmatized as ein, and here dem is lemmatized as der. We then have the part of speech. So many CONL formats use a coarse and a fine part of speech. So we have a coarse part of speech here, verb, and a fine part of speech, verb modal finite, I guess is VM thin. We then allow some kind of inflectional information, some kind of particular information. So we can say, for example, here dürfen is plural, third person, present indicative. So it gives us an idea of which form of the verb we're using. And finally, we have the dependency structure. So this is a little bit hard to understand, but basically what it says is that this word here is linked to word number 2, so in this case dürfen, with property SB, which is subject. So it says that Sie is linked to dürfen, where Sie is the subject of dürfen. And then, for example, here this refers to number 4. So this is I'm referring to number 4, which is copy, and NK is, I'm not actually quite sure what NK stands for. It's somehow linking the article to its verb, obviously, but I don't know what it stands for. So this gives us a dependency structure. So this can be converted to RDF very simply. So we can just do the same sort of generic procedure for converting tab-separated values into RDF, where we simply define each row as having its own URL, and then we introduce a triple for each column. So there is word is Z, lemma is Z, and so forth. So we introduce just one triple for every cell, effectively, in our TSV document. So that's nice, but it also doesn't capture, but here we're actually trying with 2 triples to introduce a link. So we can improve this slightly by actually including the information about how, oh, sorry, I missed something important. And then, of course, because, as I said, RDF has no order, we also need to introduce next word as a property between our words in the sentence. So we keep the structure and the order of the words in our annotation. So a slightly better representation is to actually convert this dependency link into a triple. So we can have a triple here, it says SB goes from node 1_2 to node 1_1. And if we follow this gives us a nice tree. So we can have a tree like this as an RDF graph. So Sie dürfen, here I've added in the 12 word, which was installieren in this example. So Sie dürfen eine Kopie der Software installieren. So this gives us a parse tree as an RDF graph, and as it's an RDF graph, this means we can query it with Sparkle and we can do nice NLP applications fairly easily. So that's kind of all I have to say really about corpus annotation. So RDF is actually a pretty powerful method of representing corpus annotations. It's not too well adopted so far, and it can be a bit verbose and hard to read. This is often the problem of RDF, and of course there's really no tool support at the moment, but this should be changing over the next few years, in part thanks to this project and this project. We'll move back to the world of lexicons, because this is the world I know and I'm familiar with, and corpora are fun, but it's not so much my research. And we're going to look into a particular class of lexicons called WordNets. So, who here hasn't heard of WordNet? Good. I'm glad that everyone's heard of WordNet. So, I'm going to talk a little bit about some of the developments we've had in recent years of WordNet, starting with this idea of the global WordNet grid, so sort of relates to your question earlier about WordNets. So WordNet started in Princeton. They created an English WordNet in the early 90s. And then, well, in fact, in 1990, so I have the time here at the bottom. And this sort of gained popularity, and then by the late 90s, there was a project called EuroWordNet that started creating WordNets for other European languages. This then spread to a lot of more projects. So in the early 2000s, there was Multi-WordNet, which is another European WordNet, Balkanet, which was East European, and Indo-WordNet, for example, in India, studying the Indian languages. And then it spread a bit more. We had Asian WordNet. In 2000, by 2009, Princeton WordNet has released 3.0, which is effectively the last version of Princeton WordNet so far. And then some more things pop up. We start to end up with some open WordNets, like in Portuguese, and Francis Bond in Singapore starts creating this multilingual WordNet grid. So this is great, but there's a lot of problems with all of these, the way that the WordNet has developed so far. So first of all of these projects end up with some different definitions. They have very different definitions of synonymy. how particularly close a word has to be synonymous. They use different, they're all projects because they were created by researchers, and researchers have to research, so they have to do something innovative. So of course they all introduce their own relationships that are different. They also then interpreted the relationships that were already there differently. But also because of the strong effect of the English principal WordNet, there was this very Anglo-Saxon view that sort of permeates WordNets in other languages. And of course, whenever we have updates to principal WordNet, then all the other WordNets are now out of date. So we have this kind of problem of versioning. And it actually turns out that out of the 20, out of open multilingual WordNet, which has something, I think, just shy of 40 language WordNets, there are 25 SYN sets that are in all WordNets in all different languages that are available, which is, well, 0% effectively. Out of 117,000 SYN sets, only 25 are in all WordNets. So the solution to this we've been introducing is the CHILI, or the Collaborative Interlingual Index. And the idea is this: we'll try to merge all of the WordNets around a single interlingual shared conceptualization. So rather than having English WordNet as the basis, or Princeton English WordNet as a basis, we'll have these ILI index values. And this, of course, is available as open source and linked open data, and so forth, and all of the things we've seen so far. And we effectively define a concept in an interlingual manner with the following things. First of all, we give it a unique and permanent URI, so we have a name for it that is fixed. Unique and permanent also means that no matter what happens, we're never going to delete a concept. At best, we might say this concept shouldn't be used anymore, it's deprecated, you should use this concept. But ILI concepts are unique and permanent. They have at least a good English gloss. Why English? Well, the same reason why I'm talking to a class of people. Very few of you are native English speakers, but we're all using English because it's the language of science. So it means that at least we hope that most WordNet creators can understand an English gloss and can write an English gloss. And it has a link to at least one other SYN set. So this is our minimum requirements for defining a concept. So an English definition, a link, and the fact that once it's accepted, it's never going to go away. You can guarantee that these codes are going to be there forever. So why might this be useful? Well, we might want to introduce some kind of cross-lingual mapping that we wouldn't have in English. So for example, this is a German Lehrer, this is a German Lehrerin, this is an Italian professore, this is an Italian professoressa. But if we want to link everything through English, English has this word teacher. And that's a teacher, and that's a teacher, and that's a teacher, and that's a teacher. So this means that we actually end up losing this distinction that Germans would have between our female Lehrerin and our male Lehrer, which is also represented in Italian between our professore and our professoressa. So we lose this mapping. So the idea of having an interlingual conceptualization is, even if a term isn't, a concept isn't lexicalized in English, that doesn't mean that English people can't think of this concept. A native English speaker understands what a female teacher is, but we don't have a word for it other than female plus teacher, which is compositional. So the idea is that we can introduce interlingual concepts. We can introduce our new interlingual concept, I1, 2, 3, 4, 5, 6, and I1, 2, 3, 4, 5, 7. We would introduce this idea of there being a male teacher, which can be glossed in English as a male teacher, has a link to an English SYN set, so it can be said as this is a kind of teacher, a male teacher is a kind of teacher. And then we can actually do a link to German and the Italian directly. So this is kind of the goal of having interlingual concepts. Maybe let's skip that slide. So in order to do this, of course, we need to get a lot of information from our individual WordNets. So we introduced a common format based on the OntoLex model, but for simplicity, it's actually XML based as some people felt this was easier to work with. But this follows basically what we've seen in OntoLex. So we have a lexical resource, which consists of lexicons, which consists of lexical entries with lemmas and forms and senses. And then instead of having ontology entities, because in WordNets we have synsets, and synsets have definitions and relations. So this is an XML format, so it's constrained with a DTD. So here we have our header. We simply say it's a lexical resource for XML declaration. And then we have our lexicon, and we can give a lot of metadata about our lexicon, like the ID, the label, the version, the language. That's the language here, not there. The author, the citation if we want, the license URL, and so forth, and homepage, and so forth and so forth. So we can give a lot of metadata. And then our lexical entries are fairly straightforward. We have a lexical entry, it has an ID, has a lemma instead of, which is like the form in OntoLex and is mapped to the form in OntoLex with written form, and a part of speech. We have a sense, and the sense then has a relationship, say derivation, targeting another sense. So we have a unique ID, part of speech from a fixed category. Our IDs have to match a synset element, and our senses have to match a sense element. We then have our synsets. Synsets are defined as another XML tag with IDs, the ESSLLI code, so this is the international code here, the part of speech, the definition in English, and the synset relationship, for example, hypernym to another synset. So this is sort of the idea of introducing this, which is all great. So everyone can create WordNets now, they can upload it to Chile, they can start defining their interlingual concepts. But our first fear, of course, is that in our case, for example, of the German Lehrerin and the Italian professoressa, that the Germans might define their concepts, the Italians might define their concepts, and we end up with two versions of the same concept, so two identifiers. So a key part of this is linking. So we did some experiments on linking, particularly looking at linking into Wikipedia. And so for Wikipedia linking, we first of all noticed that there is actually quite a difference between what we have in WordNet and what we have, say, in Wikipedia. So in WordNet, we have yellow. We have yellow as a verb, and a noun and an adjective. So page is yellowed, for example, it's a verb. And we have lots of secondary synonyms, for example, cowardly. So someone is yellow, they're a coward. Or a yellow as in a warning in soccer. So we get particular senses like this of the word. And this is sort of a lexicographic understanding of yellow, where we're distinguishing between how the word is used, that is noun, verbs, and adjectives are different senses and different lexical entries, as you remember from yesterday. Whereas if we look in Wikipedia, well, we also see the same primary sense, yellow as a colour, but in Wikipedia, of course, we merge whether this is as a noun or verb or adjective, as yellow as a concept, like the ontological point of view. And as well as yellow as a colour, there's also 2 books, 8 films or songs, 8 films, 4 songs, and a butterfly are all have the name yellow as a Wikipedia article with something after it in brackets. So this means that we have quite a different idea between what yellow means in an encyclopedia like Wikipedia against what yellow means in a dictionary like WordNet. So Princeton is also a lexical resource and not an encyclopedic resource, but it contains certain properties that are quite encyclopedic, like place names, and it has a certain Anglo-Saxon, maybe even northeastern US bias. So for example, in WordNet currently we have a synset for Paterson, New Jersey, with a population of 150,000. Well, that's not very far from Princeton. Princeton's a bit off the map down here, but not that far away. Whereas there might be a city 10 times the size in Japan, like Kawasaki, and Kawasaki is not there. So WordNet perhaps can't and shouldn't be listing a lot of place names, because that's not really its role as a dictionary. And if you were to introduce all of these cities, every city in the world with a population of over 150,000, you'd probably double the size of WordNet and not really make it much more useful for the applications that it's needed for. So, whereas Wikipedia, on the other hand, also tends to slip a bit into trying to be a lexicon. So there are Wikipedia pages for things that are, I would say, not particularly encyclopedic, like play. So there is just an idea of playing. There's a Wikipedia article for it. It's not particularly interesting because I don't know why you need a encyclopedia to explain to you what playing is. And it includes some great images in case you're confused about what playing is, like a dog playing with a ball, or a cocker spaniel playing with a monkey doll, or whatever's going on in this photo. This is play, and this is, I think, how our robot overlords will understand play when they take over from the Wikipedia article. So there is certainly some kind of overlap between lexical resources and encyclopedic resources. Wikipedia contains some kind of very lexical concepts. WordNet contains some encyclopedic concepts. But it would be better if these were kind of a little bit kept separate, and then we had a linking where they overlap. So this is what we tried to introduce. So we had a linking task here, and those on the right aren't very legible. The theme changed the slides. But anyway, so let's have an example of Paris. So on the left we have some WordNet concepts that have a lemma Paris. So we have sometimes placed in family Trillacia, typically not very good WordNet definition here. Paris, a town in northeastern Texas. Paris, mythology, the Prince of Troy, who something something. And Paris, comma, capital of France, so this is a synonym, the capital and largest city of France. On the Wikipedia side, we might have a page, we have a page that's called Paris. This is about the French capital. There's a page called Paris, Texas. There's a page called Paris, mythology. And there's even, if you type in Paris, brackets, Romeo and Juliet, it will redirect you to a page called Count Paris. So these are different Wikipedia pages, and what we'd like to do is create some kind of linking here. So we know this Paris, Texas is probably this one is certainly this one, this mythology one is this one, and this one probably doesn't link to anyone here. So we found that most synsets actually have at least one candidate, but there are an average of 21 Wikipedia articles that share a lemma with each named concept in WordNet. So it's actually quite a hard task. You're choosing, on average, 1 in 21 options. So our solution was to try to do category matches. So we tried to say that Paris is a hyponym of national capital, and Paris, the Wikipedia article, is in the category capitals in Europe. And if we can create this category linking, then we can distinguish the individual senses. We also use things like length-based matching. So we looked at this idea that the longer the match, the more likely it is to be correct. So, for example, here we have a synset that is Diana, Princess of Wales, Lady Diana Frances Spencer. And our targets are Diana, Princess of Wales, and Lady Diana Frances Spencer. So, in fact, Diana is about a character from mythology. Princess Diana is actually Wonder Woman. The Princess of Wales refers to the title of Princess of Wales, which of course is now held by a different person. But when we have the longest string match, Lady Diana Frances Spencer, matching to a page called Lady Diana Frances Spencer, redirects to Diana Princess of Wales, then we can be pretty certain that we've actually made a mapping here and that this is the page that we want. So the longer string matching, the less ambiguity we have. So we incorporate this into a formula. I'll skip it. And then we did this manually. We went through all linkings, and we found that there were we linked 7,500 synsets in WordNet to Wikipedia, and this gold standard data set is here. Let's say English WordNet. So this is part of some work we've done, but now, most recently, we've just we've started to improve WordNet itself. So as I said, WordNet's release schedule has been fairly infrequent. So the 2.1 release was in 2005. The 3.0 release was 2006, in December 2006, so a reasonable release schedule. And then it kind of stopped. 3.1 was released in November 2012. However, it should be noted that WordNet, the Princeton release in 2012, is actually smaller than the release in 2006. So they actually removed synsets more than they added synsets. So this was a few reasons. They got rid of a lot of proper names. They also went a bit conservative and got rid of some certain ethnic and homophobic slurs and such like, because they thought it shouldn't be in the dictionary. I disagree, but at any rate, they got rid of some stuff, so it is actually, in many ways, a less useful release than the one in 2006. And this is problematic, of course, because English hasn't stood still. So back in 2006, 13 years ago, tweeting was something birds did, spreading was what you did to toast, and exits are exits. Nowadays, tweeting is something you do online, spreading is something that men get in trouble for, and, well, we can't stop hearing about Brexit. So we see words changing senses and novel senses coming in and novel words. So it would be a good idea to try to keep WordNet a little bit up to date and try to improve it. So for this reason, what we did was we've actually now created a fork of WordNet. There is a new version of WordNet called English WordNet. So there's Princeton WordNet and English WordNet. And this is an open source development. So we have regular releases, so an annual release schedule. And it's community supported, it's open on GitHub. Anyone, including you, if you wanted to fix something about WordNet, could go to our GitHub and suggest a change, and we'll probably implement it if it's sensible. So this is sort of a bit of a difference in methodology. So in Princeton's methodology was always to use expert lexicographers, lots of review. This is all great and all, but it's expensive. Lexicographers are cheap. And getting funding for WordNet type projects is hard. So instead, we're now looking at trying to do this open source, using a version of basically what's called Linus's law. So you see Linus Torvalds of the Linux project. And his rule says, given enough eyeballs, all bugs are shallow, including apparently my inability to put a comma into a slide. And then we rely on many open source contributions. So, as I say, you can help improve WordNet if you want to. How can you do this? Well, this is through our general kind of open source methodologies. So our community contributions is really seen through two methods. First of all, by creating issues. So this is the easiest way to do. So a user can just say, I think this is wrong in WordNet. They can provide, ideally, the identifier of the synset, the type of the change they want to make, and some kind of motivation. And then a technical developer, generally me, will go and implement it. But if you are more technical, you can simply just directly make the change and ask it to be pulled using the pull request mechanism of GitHub. And there's lots of guidelines about community contribution that we've written to try to make sure that people don't make overly political changes. So we'll see. So what are the kinds of things that we're going to change? Well, we find that there's all kinds of issues in WordNet. So there's lots of cases where there's synset duplicates. So two synsets that basically refer to the same concept. So currently there's a WordNet synset for Aram Khachaturian and Aram Khachaturian, I guess. Anyway, they're not different people. The definitions are very similar. It just seems for some reason twice they wanted to add the same Georgian composure. I'm not quite sure why, but they shouldn't be two versions of this Georgian composer. In WordNet, so we need to sort of delete one, or at least under our principles of never deleting stuff, at least deprecate one and say we're only going to use this one going forwards. Sometimes synsets maybe aren't very well defined. So the synset for Dharma says, basic principle of the cosmos, also in ancient sage and Hindu mythology worshipped as a god by some lower castes. So these probably aren't a single concept. There's fairly obviously one concept, basic principles, and another concept, an ancient sage. So we probably should introduce a new synset, maybe covering the ancient sage meaning. We also then might introduce new synsets for other reasons. So for example, in the jackal, the animal the jackal is defined as synonymous to Canis aureus, but in fact there are 5 species of jackal. There's, as well as Canis aureus, there's Canis mesomellus, Adustus, latrans, and anthus. So we might want to introduce new synsets for these other kinds of jackals to distinguish it from perhaps the larger class Canis aureus. We also have lots of issues with synset members. Lemmas are, there need to be new lemmas, or lemmas need to be deleted or changed. There's a certain amount of synsets that just sort of don't refer to real things. So some synsets seem to be introduced for unknown reasons. So one example is deionate. Deionate is just not an English word. You can, looking at it in Corpus, you don't see any examples. If you Google it, you just basically get WordNet, because it's not really an English word. Now, it's probably just a mistake. It was probably supposed to be deionized, which also exists in WordNet. But it's also a case of church mouse. Church mouse refers to a particular, I think, C.S. Lewis character called Church Mouse. But you can actually search through all of C.S. Lewis's books, and he never uses this phrase. So why it's referring to a character that's never used by the author, it's claimed. It's probably a case of a deliberate error to detect copying, but we don't really know why it's there. And also things like adding relationships and changing relationships in WordNet are important too. Finally, we have some definition example errors, so where definition errors are unclear. And we're going to start including information from other English WordNet projects, like the EN WordNet project, which is in Poland, Global WordNet, which was myself before, and Chile/Open Multilingual WordNet have a long list of changes that we can incorporate too. So currently we have a lot of open issues. We're working through changing, so things like duplicates. Since duplicates appears to be the most common issue, people have a lot of unclearness about when two concepts differ, but there's also issues like new synsets and splitting synsets and changing relationships and changing definitions. We'll also then look into the future into trying to use our ELEXIS tools in order to improve how we can introduce new concepts. So, for example, semi-automatically learning links, that is, the computer suggests links between synsets and we validate it. Looking at error detection, trying to improve definitions, and whatever else the community or other people suggest we might want in the next version of WordNet. So English WordNet released its first version in 2019. This contains something like 3,000 changes. Of these, there's 797 new lemmas and 23 incorrect lemmas removed. There's 1,000 new senses, 662 new synset relationships, or 662 changed relationships, and actually 2 less in total, because there were 2 erroneous ones we removed. We added we changed 925 definitions, and we changed over 1,000 examples. So, in contrast to the size of it, it's not very different. I mean, nothing radical has changed, but it's a lot of tidying up and a lot of improving stuff around the edges. It also has this nice new interface that I wrote using Angular and Rust and Bootstrap, which is at, oh, I haven't got the URL. Anyway, its URL is en-word.net. So en-word.net. body, I wanted to talk a little bit about this. So this was a new community-supported version of WordNet. We forked it off Princeton WordNet. It's an open source framework, so anybody can contribute. Please do. It's going to be released annually, so there's going to be new English WordNets every year on my birthday. It happened to be a coincidence, but it's a nice coincidence that I think we'll keep to. And in 2019 we fixed 3,500 errors. 2020 will fix even more than this. And that's kind of all I have to tell you this morning.